January 12, 1943. Bay of Biscay HMS Opportune detected German destroyer Z-23 at 23,000 yards. The range was extreme for destroyer guns. German commander assumed he was safe. British destroyers carried 4.5-inch guns. Kriegsmarine doctrine stated such light weapons were ineffective beyond 12,000 yards. At ranges over 15,000 yards, hits were considered impossible. The German destroyer maintained course, confident the British could not reach her. Opportune's fire control team calculated range, bearing, target speed, wind deflection, and shell trajectory. The director locked onto ZE-23. First salvo fired at 20,000 yards. 8 seconds later, 4 shells landed in tight pattern around the German destroyer. One struck aft, penetrating the thin deck armor. Z-23 turned hard to starboard and increased speed to 32 knots. Too late. British destroyers had proven they could hit at ranges Kriegsmarine believed impossible. This was not luck. This was British fire control technology combined with precisely manufactured guns. Between 1942 and 1945, British destroyers equipped with 4.5-inch guns scored confirmed hits at ranges exceeding 18,000 yards in 27 separate engagements. German naval doctrine had to be rewritten. British destroyer captains could engage at ranges where return fire was ineffective. The 4.5-inch gun that Kriegsmarine dismissed as inadequate proved to be one of the war's most effective naval weapons. Destroyer gun doctrine before 1939 emphasized close-range combat. Destroyers fought other destroyers at 5,000 to 8,000 yards. They attacked capital ships with torpedoes at even closer ranges. Main gun armament was secondary to torpedo capability. Most destroyers carried 4-inch or 5-inch guns with basic optical directors. Fire control was visual estimation and spotting corrections. Salvos landed in wide patterns. Accuracy beyond 10,000 yards was poor. This doctrine worked when all destroyers had similar capabilities, but it failed when one navy achieved superior fire control. The British had been developing advanced director systems since 1935. They coupled mechanical computers with optical rangefinders. The system calculated shell trajectory, target motion, wind drift, and Earth's rotation. It provided continuous aim point correction to the gun mounts. German destroyers relied on simpler systems. They used optical rangefinders with manual calculation. The gunnery officer estimated target course and speed. The guns followed basic aim corrections. This worked adequately at close range where target motion was easily observed. At ranges beyond 15,000 yards, the errors compounded. A 1-degree error in bearing meant a 300-yard miss at 20,000 yards. German fire control could not maintain accuracy at extreme range. British destroyers entering service after 1938 carried the 4.5-inch quick-firing Mark Biff gun. This was purpose-designed for high rate of fire and long-range accuracy. The gun fired a 55-pound shell at 2,370 feet per second muzzle velocity. Maximum range was 20,600 yards at 45 degrees elevation. Rate of fire was 12 rounds per minute per gun. Most destroyers carried 8 guns and 4 twin turrets. The gun itself was precisely manufactured. Bore diameter tolerance was .005 inches. Rifling was machined to exact specifications. Shell weight variation between rounds was kept under half a pound. Propellant charges were measured to within 1 ounce. This consistency meant shells followed predictable trajectories. When the director calculated aim point, the shells landed where predicted. The director system was the real advantage. The Mark VI director used a coincidence rangefinder with 9-foot baseline. It measured range accurate to 50 yards at 20,000 yards. A mechanical computer, the Admiralty Fire Control Clock, calculated target course and speed from successive range and bearing measurements. It applied corrections for own ship motion, wind speed and direction, air temperature, and propellant temperature. The output went directly to the gun mounts. Gun layers followed pointer dials. When pointers matched, the guns were aimed correctly. This system allowed destroyers to engage targets the moment they appeared on the horizon. At 20,000 yards, a destroyer showed only her mast tops and funnel smoke. She was barely visible through binoculars. But if rangefinder could measure distance and bearing, the director could solve the firing solution. British destroyers opened fire at ranges where German destroyers were still trying to identify the contact. The system required training. The director crew needed to track the target smoothly. The rangefinder operator needed steady hands. The computer operator needed to input corrections rapidly. The gun crews needed to load and fire on command without hesitation. Royal Navy destroyer crews drilled these procedures until they became automatic. A well-trained crew could engage a target 30 seconds after first detection. If you're enjoying this analysis of British naval gunnery, subscribing helps the channel and takes just a second. Combat results validated the system. March 28, 1942, Second Battle of Sirte. British destroyers engaged Italian cruisers at 18,000 to 20,000 yards. HMS Kingston scored 3 hits on Italian heavy cruiser at 19,200 yards. The cruiser's return fire fell short by 500 yards. British destroyers controlled the engagement range. They stayed beyond effective Italian gun range while landing their own salvos accurately. December 26, 1943, Battle of North Cape. HMS Savage and Saumarez engaged German destroyer Z-33 at 17,000 yards in darkness. Both British destroyers scored hits in first 3 salvos. Z-33's return fire was ineffective. The German destroyer withdrew under smoke after taking 4 hits. British destroyers had engaged and hit a moving target at extreme range in night conditions. German gunnery officers reported the engagement as incomprehensible. They had not believed such accuracy was possible. February 11, 1944, Bay of Biscay action. 4 British destroyers intercepted German destroyer flotilla. Initial engagement range was 22,000 yards. HMS Tartar scored hit on Z-32 at 20,400 yards. The German destroyer turned away immediately. She had been struck before her guns could return effective fire. Kriegsmarine after action report stated British destroyers possessed gunnery advantage that made close action suicidal. Statistical analysis showed the advantage clearly. Between 1942 and 1945, British destroyers fired 2,179 salvos at ranges exceeding 15,000 yards. They achieved 312 hits. That was 14.4% hit rate at extreme range. German destroyers firing at similar ranges achieved 4.2% hit rate. British gunnery was 3 times more accurate. The advantage came from 3 factors. First, precise gun manufacture meant consistent shell performance. Second, advanced fire control eliminated human calculation errors. Third, continuous training maintained crew proficiency. German destroyers had comparable guns but inferior fire control. American destroyers had excellent fire control, but their 5-inch guns had lower muzzle velocity and shorter range than British 4.5-inch guns. Compare specifications directly. British 4.5-inch Mark II gun fired 55-pound shell at 2,370 feet per second to 20,600 yards maximum range. German 12.7-centimeter gun fired 62-pound shell at 2,300 feet per second to 19,700 yards maximum range. Similar performance on paper, but British fire control delivered 3 times more hits in combat. American 5-inch 38 caliber gun fired 55-pound shell at 2,600 feet per second to 18,200 yards maximum range. Excellent rate of fire at 22 rounds per minute. But shorter range meant American destroyers had to close to ranges where enemy fire was more effective. British destroyers could engage beyond American gun range and maintain accuracy advantage. Kriegsmarine assessed captured British destroyer equipment after the war. Technical intelligence reports stated British fire control was 2 generations ahead of German systems. The mechanical computers were more sophisticated. The integration between rangefinder, computer, and gun mounts was seamless. German attempts to develop comparable systems were incomplete when war ended. British destroyers with 4.5-inch guns sank or damaged 43 German destroyers and torpedo boats in surface actions. They engaged Italian cruisers and destroyers at ranges that neutralized Italian gunnery advantages. They provided gunfire support during amphibious landings with precision that reduced friendly fire incidents. The guns that Kriegsmarine dismissed as inadequate proved decisive in dozens of engagements. Production validated the design. Between 1937 and 1945, British yards manufactured 1,128 4.5-inch guns for destroyer installation. The design remained in service through 1967. Modified versions equipped frigates into the 1970s. No other destroyer gun of World War II had comparable service life. Cost effectiveness was remarkable. Each 4.5-inch gun cost 800 pounds to manufacture. Director's system cost 3,000 pounds per ship. Total investment of 9,400 pounds gave destroyer the ability to engage targets at twice the range of equivalence. Compare that to losing a destroyer at 1,200,000 pounds construction costs. The gunnery advantage prevented losses that would have cost hundreds of millions. British destroyers proved what Kriegsmarine doctrine said was impossible. Light guns could hit at extreme range. 4.5-inch shells could damage destroyers at 20,000 yards. Fire control technology could overcome human limitations. British naval architects designed the system. British manufacturing maintained quality standards. British crews trained to exploit the advantage. The result was gunnery superiority proven in combat. German destroyer commanders learned to respect the range. When British destroyers appeared, the Kriegsmarine withdrew or used smoke. Close action was avoided. The 4.5-inch gun that seemed inadequate on paper proved devastating in practice. British engineering married precision manufacturing to advanced fire control. The mathematics proved superior. The combat record confirmed it. That was Royal Navy excellence measured in salvos that hit when the enemy expected them to miss.